All right, so what is the scientific method? It's a logical, is what you're writing underneath there. It is a logical, step-by-step process to solve a problem. Everyone good now? All right. So, your steps to the scientific method. You're going to observe something. Just like my stupid caterpillars eating my plants. And then you might Google it. You might research. So this is going on the right side there. And then if I really wanted to, I would make a hypothesis. If I capture a caterpillar and feed it food, then in a week it will become a butterfly. Maybe that would be my hypothesis. It's that if-then statement. I might, within my hypothesis, be predicting, and then I'm going to experiment on it. I'm not going to lie, I've thought about doing this, but I haven't been able to find a caterpillar since, so they might already be cocooning somewhere. And then after you do your experiment, you're going to examine your results, and then you're going to come up with a conclusion. You're going to say, my hypothesis was correct or it was not correct. So maybe I capture one, or maybe I find a cocoon, and I watch it day by day by day, and I see that it actually turns into a moth. My hypothesis would be wrong then, and I have to state that in my conclusion. So, a hypothesis, for this definition, your first blank is an explanation. It's a possible explanation. You can't see it because it's kind of small. It's explanation for a set of observations. observations. That's that other blank. You always are going to put it in an if-then statement. Hypothesis, a possible explanation for a set of observation. An observation is fact. That's your first big blank there. Fact. It's using your senses to gather information. But you definitely could use taste as one of your senses for observing something. Okay? Inference. An inference is just an opinion. Alright, it's an interpretation. If you're not sure how to spell that, it's interpretation. Based on a set of observations. Alright, so you observe something and then you kind of take it a step further. For example, I observe that all of you are here today. I can infer that you all rode the bus. Is it true?
Nope.
No. Some of you guys might have walked. Some of you might have parents that love you and drop you off. Alright? But, that's an inference. It doesn't have to be right. It's kind of me seeing that you're all here and then taking it a step further. Okay? I think are some clue words. Maybe it's possible that this is happening. Alright, and that's going to help you with your hypothesis. Yes, Henry? Now let's go back to our heart rate lab. So the thing that we're doing right now, let's make a hypothesis, or maybe let's make an observation first. What have you guys observed about our heart rate lab so far? Ryan?
Alright, the last bit of this, or we're coming on to the home stretch, is keeping your experiment organized. You can break your experiment into two groups. You have the control group, which does not get the treatment. It's the normal, what usually happens. And then the control group is also used for comparison. So you're going to be doing this experiment. You need to compare your experiment to what normally happens. This can also be a before treatment. The experimental groups are the groups getting the treatment. This can also be an after treatment. Okay, so you're maybe looking at your data, and this group is going to be the group where you're actually getting the data from, which would be your after treatment. I'm going to have you guys talk in class about the heart rate lab example and what our control group or what the normal is for our heart rate lab. And then we're going to talk also about what data is going to be our experimental group. You also have variables. The independent variable is what you pick to change as the scientist, and you can also think of it as, what am I testing? What is the thing that I am changing? Because that's going to be my independent variable. The dependent variable is kind of what you expect to happen. It's the data collected, all right? So you can kind of think of an independent variable as the cause in your experiment, and then your effect or the result is your dependent variable, all right? And then you also have controlled variables. These are the things, all the other things that you want in your lab to stay consistent, to not change. They're the constants throughout the whole thing. You could have thousands upon thousands of controlled variables. You could come up with those because you really only should be changing one thing. You should really only be exploring and experimenting on one thing at a time. So we will, again, I want you to think about each of the variables for the heart rate lab, but we'll talk about it together too. If the experiment is not controlled, there's going to be more than one independent variable tested, which is not going to be helpful. If you have too many things changing, your results cannot be directly linked to a change in the independent variable. So if I'm trying to lose weight and I decide to change my diet and start exercising, that's two variables, and I can't say one way or another which one is helping me lose weight. So if you're doing an experiment, you would just want one thing changing. For example, I would want to change my eating habits and see if that actually is something that can help me control my weight. Don't worry about that. All right. For this, students of different ages were given the same jigsaw puzzle to put together. They were timed to see how long it took to finish the puzzle. You need to look at this scenario, figure out your independent variable. What are you changing? What is different? What are we looking at here? And then your dependent variable is, what are you measuring? How are you seeing if it works? What changed, or what data is going to be collected to see if this thing worked? And then 3 controlled variables. Remember, you can have thousands of these. You want all the other things that could be kept the same in this scenario. We'll talk about this also together. Ignore this guy. Here's another one. The temperature of water was measured at different depths of a pond. So what did you change? Or what is being changed? What is measured to see if that change actually does something? And then what are 3 things that you want to keep the same? Remember, you can have thousands of controlled variables.